Nth roots. We need to learn about roots in general. We have already studied square roots, and understanding those will help us to understand other roots as well. So on this slide, look at this symbol that we have. We have our radical symbol that we've already talked about for square roots, and you can see that here. It's the square root of 25, has the radical symbol on it. But notice when you write that symbol for a square root, you do not see any number written up here in the upper left. But in general, when you have a root, there is a number here that is called the index. We're using n to represent the index. The formal name is index, but it is also the root. So when it's a square root, there is really an invisible 2 as the index. The 2 indicates a square root. If the index were a 3, you would actually see the 3 written there. So square roots, you don't see the 2, it's invisible. But a cube root, you do see a little 3 there. The index is called 3. You could have a 4th root, and you would see a little 4 there indicating a 4th root. You could have a 5th root, and on and on and on. The only time you don't see the index written is for the square root. So it's an invisible 2. So this is the way we write a root in general. The nth root of a is how we would say this notation right here. A, as we've already studied, is called the radicand. Whatever's underneath that radical symbol is the radicand. Okay. So let's go back to the basics of square roots. I know we've already talked about this, but just to help emphasize what we're learning today. Okay, a square root has this radical symbol with the invisible 2, and we would say the square root of 25 is 5, since 5 squared is 25. So that's why the answer is 5, because 5 squared is 25, or maybe you prefer to think of it as because 5 times 5 is 25. And remember, when we see this symbol, we are only giving the positive square root. Look at this cube root example. We know it's a cube root because the index is 3. The cube root of 64 is 4 because 4 cubed is 64. In other words, 4 times 4 times 4 equals 64. It takes 3 of them multiplied together to equal 64. Then the answer is just the 4. The answer is not 4 cubed, by the way. It's just 4. It's whatever number to the 3rd power equals 64. Now, we made a list of perfect cubes when we were factoring, but let's go ahead and do those again here real quick. We had 1 cubed was 1, 2 cubed was 8, 3 cubed, 27, 4 cubed is 64, as we've seen in this example here, 5 cubed is 125, and 6 cubed is 216. So I'd like for you to know at least these 6 perfect cubes and their cube roots. So if I said, what is the cube root of 216? Then you would automatically know, okay, the answer to that is 6, because 6 cubed is 216. Now, what if we wanted a 4th root? The index would be 4, and the answer would be whatever number to the 4th power equals that radicand. So in this case, 4th root of 16 is 2, because 2 to the 4th, if we multiplied 2 times 2 times 2 times 2, would equal 16. It would take 4 of those 2's to equal 16, and so just 2 would be your answer. Now here's a quick way that you can find the 4th root of a number. You can square root twice. So if I'm taking the 4th root of 16, I could first in my mind say the square root of 16 is 4, and the square root of 4 is 2. So take the square root twice, and that'll help you get to your fourth root. So, as we are talking about these roots in general, we need to think about some differences in the problems that have an even index, which would be like a square root and a fourth root. N would be an even number. And an odd index, a cube root, fifth root, seventh root. Let's see some differences here. So these are problems here, square roots that we've already learned, but let's go ahead and answer. We know the square root of 9 is 3 because 3 squared equals 9. And we know that when we give this radical symbol that we need just the positive answer. When there's a negative sign in front, we keep that negative sign. And then the square root of 9, 3. So we would answer a negative 3 on row 2. Now on row 3, we just learned in the last video that if there's a negative under the square root, we get an I. So the answer to that is 3I. And the reason for that I was because we cannot square a number and get a negative result. All right, now look at these cube roots. The cube root of 8 is 2 because 2 times 2 times 2 equals 8. If there's a negative sign in front of the cube root, you keep the negative sign just like you do for a square root, and then you would answer, okay, the cube root of 8 is 2. So my answer for the whole thing is negative 2. Now, cube root of negative 8 does not have an I. Cube roots will never have I. Let's make a note of that because a lot of students make that mistake. Cube roots never use I. There's no need for I because it is possible to take a number to the third power and get a negative result. It is not possible to take a number squared and get a negative result. That is why the square root has the I, the cube root does not. So the answer to this is actually negative 2. The reason is negative 2 cubed is negative 8. If we do negative 2 times negative 2 times negative 2, that would be positive 4 times negative 2 would actually equal negative 8. So we can get an answer here that to the third power is equal to that negative 8. So it's the same reason that 2 is the answer to this first problem. It's because 2 times 2 times 2 is 8. So when you have a negative inside a cube root, it basically just means you're going to get a negative answer. Okay, with that in mind, let's work some examples. So number 1, the cube root of 125. All we need to give is the number that when we cube it equals 125, and that is 5. That's one you're going to want to memorize. Number 2, we have a fourth root. And the easy way to do that is to square root twice. So first we think square root of 81 is 9, and the square root of 9 is 3. Now if you want to check that, and we could check this one too, how we would check it would be to take that answer, in this case to the third power, and make sure that that does equal 125. Here, we would take our answer to the fourth power and make sure that that does equal 81. Well, 3 times 3 is 9, and 3 times 3 is 9, so 9 times 9 does give us that 81. Now notice when I'm writing the answers, the radical comes off. There's no radical in the answer on these. Look at number 3. We've got the cube root of a negative number. There's no I for cube roots. That negative just means our answer's negative. And the number to the third power, that's 216, is 6. So our answer's negative 6. And if we check it, we would have to take negative 6 to the third power. So it'd be negative times negative times negative, which would result in a negative. So that's how we know negative 6 is correct. Number 4, we've got a square root this time with a negative underneath. Now we know we can't square a number and get a negative, so this is where the I comes in. We're still going to square root the 121, which is 11, and the negative turns into the I. So that answer would just be 11I. Okay, here we're taking a fifth root. So the concept is, if I take the fifth root of something that's to the fifth power, then I end up just basically canceling those out and getting just the x. And of course that works, checking it just like the other problems. If I take my answer to the fifth power, I should get whatever my radicand is, which certainly I do, and it's kind of weird to think about it that way. But basically you want to just, when these two are the same, you're going to get just whatever that base is that has the exponent on it. Same thing here on number 6, even if it's a whole expression, if these two are the same, they basically cancel each other out, and my answer would just be x minus 2. Now, let's go back for a second to this. We've talked about that when we have this square root symbol that we always have to have a positive answer, and there were times that we used the absolute value bars, like if I did square root of x squared, to make that answer positive we put absolute value bars on it. Now when it's a cube root, you will never need absolute value bars because it's okay to get a negative answer. This is a positive out in front of my radical symbol, but my answer's negative. So it can have a negative answer. So let's go back then to that note at the bottom of this slide. It says absolute value is not needed with odd roots. So here my root was 5. I don't need to put bars on my x. Here my root was 7, odd, so no bars are needed. Only even roots have to have positive answers. Okay, the next thing we want to think about are variables. Variables are perfect squares when their exponents are multiples of 2. Perfect squares. So that would be like x squared, x to the 4th. Maybe we should label. These are perfect squares. X squared, x to the 4th, x to the 6th, and so on. Then it says variables are perfect cubes when their exponents are multiples of 3. So perfect cubes would be x cubed, x to the 6th, x to the 9th, and so on. Variables are perfect fourth powers when exponents are multiples of 4. So perfect fourth powers would be x to the 4th, x to the 8th, x to the 12th, and so on. And we could certainly keep going to perfect fifth powers and on and on. Now here's an important statement. A quick way to take the root of a variable is to divide the exponent by the index. And before we work these examples, look at this statement. It says, assume variables represent positive real numbers. And when that statement is written in the instructions, that's basically just telling you, you do not have to worry about putting any absolute value bars on there. We're just going to assume all these variables are positive, and thus we don't have to worry about the bars. Okay, So if I have a square root, remember the index is an invisible 2. So to take the square root of x to the 16th, I still keep that base of x, and I take the exponent, 16, divided by, we'll go ahead and write that out this time, the index, which is 2, and so I end up with x to the 8th. Now I put this one specifically on here because a lot of times when students see this problem, they want to square root the 16 and answer x to the 4th. But it doesn't work that way with exponents. It's just divide the exponent by the index. Now let's check it. Like we checked the other problems. If this is a correct answer, I should be able to take that answer and square it and get my radicand back. Well, remember your exponent rules. They say when you have a power to a power, you multiply those. So it does equal that x to the 16th. Or another way you could think about it is if I do x to the 8th times x to the 8th, then that does give me that x to the 16th. Okay, so number 8 is also a square root, so an invisible 2. Then all I have to do is take my exponent divided by my index. So my answer is just y to the 5th. Number 9 is a cube root. I'm still going to take my exponent divided by my index. So that's 12 divided by 3, which is x to the 4th. Now all of these examples we're doing here are perfect powers, right? We know x to the 12th is a perfect cube because 12 is a multiple of 3. And these are the only type we're going to do right now, is those variables that are perfect powers. Okay, c to the 20th. Now, this is a perfect 4th power because 20 is a multiple of 4. To take the root, the 4th root, we would take the exponent 20 divided by our index 4, and that would equal 5. So our answer is c to the 5th. So we kind of already did some roots of variables when we were factoring, but this just emphasizes that a little bit more, and there will be some like this to practice in the homework. I'm going to go ahead and stop the video here, and then I will have one more video for this section.